Hi, so I'll show you how to do lab 1 of ECE 285 using the 82 and a multimeter. So part 1 of the lab is to measure the resistance of 15 10K resistors. So first what you can do is place your 10K resistor in your breadboard and then place your multimeter in parallel with the resistor, and then turn your multimeter onto the 20K setting, and then that would be the nominal value of the resistance, and then you would do this 14 more times. So for part 2, the objective is to verify Ohm's law using a circuit with a 1K resistor and an LED, and the objective is also to measure the current with varying DC supply voltage. So first let's create the circuit. So you have a 1K resistor in series with an LED that's in forward bias, so perfect. So the longer end connects to the one end of the resistor, and then you want to supply voltage. So you want to just grab your flywire cable, connect it to your 82. Make sure it's not loosely connected. It can look like this is connected right now, but actually it's not. So you want to like lift up and then push in, sorry. And then you want to grab your red cable. So since we're supplying 2 to 10 volts for the 82, you want to connect the red cable, which is the positive power supply, to the one end of the resistor, and then you want to grab the white cable, which is your negative voltage supply, and then I'll attach a white cable jumper cable to that, and then connect that where your ground is. And then you want to measure the current, so you want to place your multimeter in series with the LED, and then set it to measure current. And then let's go to waveforms, go to supplies, and so we're supposed to supply 2 volts and 2 to 10 volts at increments of 2. So since we're using both the positive power supply and the negative supply, we want to supply half to each. So if that's 1 and that's -1, we're supplying 2 volts. So if you turn it on, you can't see the light turn on. But if we wanted to supply 10 volts, which would be supplying positive 5 volts to the positive supply and negative 5 volts to the negative supply, you can see, not see, there we go, my wire was loose. Now you can see the current, and then you can also see the LED light up. And let me just redo 2 again. You can see barely any current, almost none, and you can see the LED didn't light up. And next, what you would do is you would do the increments of 5, and then you would replace this 1K resistor and use a 10K resistor and do the same process again. So for part 3 is verifying Kirchhoff's current and voltage laws. So you want to first create the circuit, and since we're supplying 10 volts, we will need to use the positive supply as well as the negative supply. And then this 10K resistor I will replace with the 1K resistor just to change it from the lab manual. So to create this, you have supposed to be a 10K, but now I'll use a 1K resistor, and you have a parallel branch of 8.2K resistor, and then you have a 4.7K resistor, and these both are supposed to be in parallel, but I'm gonna measure the current across this 4.7K resistor and simultaneously measure the voltage. So since this multimeter can measure current, I'll use this. The 82 cannot measure current, so I won't use I will use the voltage source from this, the voltmeter. So first you will need 2 scopes. So scope 1 is your orange cable, so your orange cable, solid orange cable, and then your orange cable with the white line. The orange cable with the white line is your negative terminal, so I will connect a lighter orange color to that, and then place that across, one terminal with that resistor, and then grab the positive terminal or the orange cable, connect the orange jumper cable to that, and place it on the other side of that 4.7K resistor. make sure my supplies are connected. Perfect. Okay. And so now we can go to waveforms, and since the supply voltage is 10, we want to supply 5 volts to each supply. And then as you can see the current. You can see there's some current. And then you can observe the voltage by clicking plus, or you can click on welcome, go over here, and then clicking on voltmeter, and then click run. It was loose, so dang it. There we go. Okay, perfect. Now you can see the current. There we go. And that is what it's supposed to be with a resistor of 1K instead of 10K. When you use a 10K, these values, that voltage value right there and that current value will differ.